All right, hi class. In this video, I'm going to show you how to run an independent samples t-test in SPSS. So to show you how to do that, we're just going to work through an example together. So in a classic study of problem solving, Doctor asked subjects to mount a candle on a wall in an upright position so that it would burn normally. One group of subjects was given a candle, a book of matches, and a box of tacks. A second group was given the same items except for the tacks and the box were presented separately as two distinct items. The solution to this problem involved using the tacks to mount the box on the wall, which creates a shelf for the candle. So Duncan reasoned that the first group of subjects would have trouble seeing a new function for the box as a shelf because it was already serving a function holding the tacks. So for each subject, the amount of time needed to solve the problem was recorded. Do these data indicate a significant difference between the two conditions? Use an alpha of 0.05. So here are our data here. You can see that this is a between subjects design, or that we have two independent groups. One group was presented a box of tacks. The other group was presented the tacks in the box separately. And so the objective was to use the box to mount the mount the box on the wall, so the candle could stick on, the candle could set on the box. And so we recorded the time it took people to accomplish this task. So if these were the data then we collected, we would need to enter them into SPSS. The first thing we do in SPSS, we open SPSS, we click on the Variable View tab. And we have to create two variables. So our independent variable in this case are the different groups, right? So we have one group, we'll call it Group 1, who was presented the box of tacks. We have a second group who are presented the tacks and box separately. So you could have actually assigned any value you wanted to box of tacks or to your two groups. You could have used 0, 1, you could use 1, 2, you could use 33, 24. It doesn't really matter. You just need to tell SPSS, hey, I'm going to use the number 1 to represent box of tacks. I'm going to use the number 2 to represent the group that had taxes and box separately. We also need to name our dependent variable. We're just going to name it time, right? Because there was a time that it took to solve the problem. Now we click on our Data View tab. And notice, so person 1 was in Group 1 that we called box of tacks, and it took them 128 seconds to solve the problem. So that's what we enter in SPSS. Person 1 was in Group 1, the box of tacks, and it took them 128 seconds to solve this problem. Person 2 was also in Group 1, and it took them 160 seconds to solve this problem. Person 3 is in Group 1, and it took them 53 seconds to solve the problem. Person 4 is in Group 1, and it took them 101 seconds to solve the problem. Finally, person 5 is in Group 1, and took them 94 seconds to solve the problem. Person 6 now is in Group 2, and it took them 42 seconds to solve the problem. Person 7 is in Group 2, took 24 seconds. Person 8 is in Group 2, took 68 seconds. Person 9 is in Group 2, took 35 seconds. Person 10 is in Group 2, and took 47 seconds. So that's how to enter the data into SPSS. You can see that in the handout as well. You have each column in SPSS represents your variable. So our independent variable is the group that they were in, whether they received the box of tax or the tax and box separately. And our dependent variable then is the amount of time it took them to solve the problem. So to run this analysis in SPSS, we click on Analyze, Compare Means, Independent Samples, T-Test. So this test variables here is where we bring our outcome, but our dependent variable, what variable we want to test. We want to test differences in time. Bring time over here. And then our grouping variables are independent variable, which variable represents our groups. We just called it group. And then you have to tell SPSS, well, what numbers did you use to represent the groups? Well, we use number 1 for group 1 and 2 for group 2. So enter a 1 and 2. You know, if you use 0 to represent group 1, you'd put a 0 here. If you use 1 to represent group 2, you'd put a 1 here. We used 1 and 2. So this is just where you tell SPSS which numbers you used. If you want to change the confidence interval SPSS calculates, you click on Options, and you would change it right here. If you wanted the 99% confidence interval, you type in 99. If you want the 95% confidence interval, you type in 95. I believe it defaults to 95, so if you don't change it, it'll give you the 95% confidence interval. So click OK, and then your output will come out. I've ran this one twice. So the first thing you'll see in the output are your just some descriptive statistics. We see group 1, which was the box of tax groups, had 5 people. It took them on average 107 seconds to complete this task, with a standard deviation of around 40 seconds. The second group who received the tax in the box separately, there were 5 people in the group. It took them on average around 43 seconds to solve this problem, with a standard deviation of around 16 seconds. So the first thing we look at is this Levine's test for the equality of variances. This tests the assumption that we make an assumption in the independent samples t-test that the population from which the populations from which the samples were drawn have equal variances. We wouldn't expect the sample variances to be exactly the same, even if they come from populations with equal variances. So we want to test for whether or not we meet this assumption. The null hypothesis in this Levine's test is that the population variances are equal. There's no difference in the population variances. Remember, the null hypothesis is typically the hypothesis of no difference, and that's what we want in this case. We want the population variances to be the same. So the first thing we do is we look at the significance level of this F statistic. Since the significance level, or the p-value, is greater than our alpha level of 0.05, we fail to reject the null hypothesis. When the p-value is greater than your alpha level, you do not reject the null hypothesis. And so in this case, the null hypothesis is that the population variances are equal, which is what we want to meet the assumption. So we can then read this equal variances assumed line right here. If this p-value is less than our alpha level, so if this p-value was small, it was less than 0.05 in this case, that would indicate that we do not meet the assumption of homogeneity of variance. If that's the case, we read this second line on here. So since we met the assumption of homogeneity of variance, we'll read this first line. And we would then look at the p-value for our t statistic. Since our p-value is less than our alpha level of 0.05, we reject the null hypothesis that the population means for these two groups are equal. And we can look at the two group means then and say, hey, those who received the task in the box separately completed the task quicker than those who received the box of tasks. Right? Even if there were no differences between these two groups in the population, we wouldn't expect the sample means to be exactly equal. So that's what we're testing for in this test. Is how different do these means have to be before we're confident that there is an effect going on here. Right? That's what this probability level is telling you. It's saying that there was a 1% chance, a 1.1% chance of observing a mean difference of 64 seconds, given that there was actually no difference between these two groups in the population. Well, we're saying that's a very unlikely outcome to occur if that null hypothesis is true, that the two means are equal. So we're going to reject that hypothesis that the two means are equal and conclude that they are different. So that's how you conduct an independent samples t-test in SPSS. Remember, you got to analyze, compare means, independent samples t-test. You bring your outcome variable over to the test variable. You bring your grouping variable, your independent variable over to your grouping variable. You have to define the groups here. You have to tell SPSS we label group 1, 1, group 2, 2. Change your confidence interval here. And you click OK. Remember, the first thing we look at is this Levine's test. If we meet the assumption, if the p-value here is large, we read the top line. If your sig value here is less than your alpha level, so in this case less than 0.05, we do not meet the assumption of homogeneity of variance, and we read the second line. When we don't meet the assumption of homogeneity of variance, we make an adjustment then to the degrees of freedom and to the standard error. You can see the adjustment being made here. There wasn't an adjustment made to the standard error here because the sample sizes were equal. When the sample sizes are unequal, you'll see a change here. But anyways, that's how we run an independent samples t-test in SPSS. As always, if you have any questions, let me know. Thank you.